Okay, now we're going to do the questions pertaining to chapter 7, probably 8.1 as well. It's all normal probability. So we'll begin with question 22. The highest point on the graph of the normal density curve is located at what? Let me show you here. This is the highest point right here. It is located at the mean. So it's the mean. Next question. 22, 23. The graph of the normal density curve is given. Use the graph to identify the value of the mean and the standard deviation. As you can see, guys, the mean is 97, and the standard deviation is the difference between the mean and the next point. So it will be from 97 to 106. How many did we add? 9. So that's the standard deviation. 24. The weight of a 2-year-old Hyraxes is known to be normally distributed with a mean of 2,200 grams and a standard deviation of 365 grams. Draw the normal curve. Okay, here's how we draw the normal curve. I'll do it right here. This is so the mean is 2,200. Then we have to add a 3 standard deviation to the right and 3 to the left. And every time you add 365, so if you add 365 will be 2565, and then if you add another one is 2930, and here you subtract 365, subtract another 365, and so on and so forth. Shade the region that represent a proportion of Hyraxes who weighed more than 2,930. More than 2,930 means, guys, it's to the right of 2,930, so this is the shading right there. The next part, he says, provide an interpretation. Suppose the area under the normal curve to the left of x is 2,930 is 0. To the left of x equals 2930. Well, actually that should be to the right. We're doing it to the right here. 0.0228. Provide 2 interpretation for this result. You can say that the proportion of Hyraxes who weigh more than 2,930 is 2.28%. This is one way. Or the probability of selecting a Hyraxes whose weight is more than 2,930 or more is 0.0228 or 2.28%. So these are the interpretation. Number 25. Find the area under the standard normal curve to the left of z equals 1.5. And this is where I'm going to start using technology. I'm not going to use in the table. So you will go to second, variables, and this is the main formula you will be using in this chapter. It's normal CDF. Now the normal CDF requires 4 arguments: lower bound, upper bound, mean, and then what? Standard deviation. So you have to provide those 4 values. Here to the left of z equals, how does the z curve looks like? This is the z curve. It's a 0 in the middle. For z, the mean is 0 and the standard deviation is 1. 1, 2, 3, negative 1, negative 2, negative 3. So we need to the left of 1.5. Let's say 1.5 is right here. And we need the area to the left of 1.5, so it's going to be right there. This is the area from 1.5 and below. So how do you do this one using the normal CDF? It will be normal CDF. Okay, lower bound, as you can see, it's a bound on the left. There is no limit for the bound of the left, so I suggest you use a -1,000,000 always, or -1,000,000,000. Just put as many zeros. The upper bound is 1.5, because you cannot exceed 1.5. When you work with z, guys, the mean is always 0 and the standard deviation is 1. How do you use the calculator to do this? Here's the calculator screen. Second, distribute, and it's number 2. You're going to be using it a lot. So negative a million, upper is 1.5, 0, 1, paste, and then you get the answer, which is 0.9332. Now if you guys don't have this screen, if this screen doesn't pop up, you're just going to get normal CDF with parentheses open. So you do this just like I did. You put negative a million, and make sure when you use a negative sign, you use this sign right here, not the minus right there. This is the negative sign. And then you put the upper bound, you put 0 and 1, and then you should get the answer. Number 26. Find the area under to the right of z equals 1. Let me show you to the right of z equals 1 how this is going to be like. So this is 0. This is the one, and right to the z equal 1, it's this area. Okay, so that will be what? Normal CDF. What's the upper bound here? The upper bound is what we start with. It's 1. Sorry, the lower bound is 1. The upper bound is, the sky is the limit, so you'll do a million here. And then 0 and 1, and then you get the answer. Let me show you the answer here. So it's a 1 million, 0, 1, paste, 0.1587. Next question. Find the area under the standard normal curve between z equals negative 125 and 1.25. So this is your lower bound, and this is your upper bound. So it will be normal CDF, negative 1.25, 1.25, comma 0, comma 1. And then if you use your calculator for this one, you will get 0.7888. Number 28. Determine the area under the normal curve between 1 and 2. It's just exactly the same as above. So it's normal CDF again. Your lower bound is 1, your upper bound is 2, your mean is 0, your standard deviation is 1. And if you do the math, you will get 0.1359. Number 29. Assume that the random variable x is normally distributed with a mean of 50 and standard deviation is 8. What's the probability of x less than 60? So let me just show you a sketch here. So this is the mean here, 50. The 60 right here, less than 60, guys, will be this area. You can see there is no lower bound. It goes to negative infinity. So this is going to be probability of x less than 60, normal CDF. You need negative a million for the lower bound, 60 for the upper bound. The mean is not 0 here. We're doing x, not z anymore. So it's 50, and the standard deviation is 8. And let me show you what the answer would be right here. Normal CDF, so negative a million. You can put as many zeros as you want. 60, 50, 8, paste, and the answer is 0.8944. Number 30. Suppose a brewery has a fire filling machine that fills 12 ounces of bottles of beer. It is known that the amount of beer poured by the filling machine follows a normal distribution with the mean of 12.35 and a standard deviation of 0.04. Find the probability that the bottle contains fewer than 12.25 ounces. So we need the probability of x less than 12.25. Anytime, guys, you have a less, you have to start with negative a million or billion, whatever. And anytime you have a more, you will put the first of the number that's given to you, and then you put a million. So that's a negative million. Then what? 12.25. Then the mean, which is what? 12.35. Then the standard deviation, which is what? 0.04. So let's do this quickly on the calculator. Second, and distribute normal CDF. Okay, I already have this. So I need to enter 12.25. And then I need the mean 12.35. and then 0.04. So it will be 0.0062. Next question, 31. A firm believes that the internal rate of return for its proposed investment can be best described by a normal distribution with mean of 42% and a standard deviation of 3%. What's the probability that the internal rate of return for the investment will be at least 37.5%? So we want the probability of X more than 37 or equal percent. Well, this is normal CDF. You want 37.5 and up. So your lower bound is going to be the 37.5. Your upper bound is whatever, million. Your mean is 42. And your standard deviation is 3. Let's see what the probability will be right here. So let me just do it. Normal CDF, so I got 37.5, 1 million, 42, and then 3, paste. If you guys get normal CDF blank parentheses, you just enter those 4 values and put a comma in between if you have an older operating system on the calculator. 0.9332. All right, next question. Uh, 32. Assume that the random variable x is normal distributed mean equals 8 and standard deviation is 8. What's the probability of x between 58? That should be very easy. Normal CDF. The lower bound is 58. Upper bound is 90. Mean is 80. And standard deviation is 8. How do you use this one? Using the calculator again. Second and distribute. Normal CDF. You see how much we use this calculator already. So it's 58, 90, 88, paste, and I got 0.8914. Okay, 33. Now it's section 7.2 where we are given the probability and then we need to find the x or the z value. So these are different. Find the z-score for which the area under the standard normal curve is to its left is 0.09. So he gave us the area here, which is the probability, which is the same as the probability. And he wants the z-score. If he gives you the area to the left, guys, it's very easy to find the z-score or the x value by using the next function, which is called inverse norm. So let me show you this one. Clear the screen. Second distribute. You can see after normal CDF there is the inverse norm, and you need 3 arguments: the area to the left, the mean, and the standard deviation. Well, he gives us the area to the left to be 0.09. Since it is a z-score, he doesn't need to give us mean and standard deviation. 0.1 by default. You get this one. Now, if you guys have an older operating system, you're going to get inverse norm parentheses. So you fill in the blanks. You put 0.09, comma 0, comma 1, and you should get the answer, which is negative 1.34. So by default, this function needs the area on the left. 34. Find the z-score for which the area under the standard normal curve to its right is 0.07. Well, if the area to the right is 0.07, what would be the area to the left? It would be 1 minus 0.07, which is 0.93. So to find z would be inverse norm 0.93, comma 0, comma 1. And then you get the answer, which is going to be 1.48. Now, some students might have a calculator that says left, right, center. If you have the calculator that says left, right, center, you can put inverse norm 0.07, but make sure at the bottom select right, because he gave you this to the right. and then you should get the same answer. 35. Determine the two z-scores that separate the middle 96% of the distribution from the area and the tails to the standard normal distribution. Okay, here is how we do this one. There are two values that separate the middle 96%. So this is 96%, and he wants this z and this z. So one is going to be negative and one is going to be positive. Here's how you can do that, guys. If there is 96% here, so what's left for the tail? 4%. But if you split them up, you get what for each one? 2%. So the area to the left of z1 is 2%, and the area to the right of z2 is 2%. So I'm going to find only one, and the other one will be opposite in sign. So that will be inverse norm 0.02 comma 0 comma 1. And if you check the answer, it will be negative 2.05. So if z1 is negative 2.05, you can be sure, guys, that z2 is what? 2.05. 36. The amount of corn chips dispensed into 24-ounce bag by the dispensing machine has been identified as possessing a normal distribution with mean of 24.5 and a standard deviation of 0.2. What chip amount represents the 67th percentile? Then he's giving you the probability here. 67th percentile is the area to the left of this amount. So we use inverse norm, but this time is not z, it's x. Inverse norm 67%, you just write it like this. What's the mean here? Is not 0.1 because it's about x now. 24.5, and then the standard deviation is 0.2. Let me do this with you. So that will be second distribute inverse norm 0.67. Mean is 24.5, and standard deviation is 0.2. It's 24.59, or if you want to round it to one decimal place, 24.6 ounces. 37. The Board of Examiners that administers the real estate broker's examination in a certain state found that the mean score on the test was 410 and the standard deviation was 72. If the board wants to set a passing score so that only the best 10% of all applicants will pass, what should be the passing score? So only the top 10% pass. Look, this is the 10%. The top should be on the right here. And we need to find this x value. Well, if the 10% is to the right, so how much area is on the left? 90%, and we need it for the formula. So x will be inverse norm 0.9 says 410 72. And let's see what the answer would be. Second, distribute normal, not normal CDF, I used the wrong formula. Second, distribute inverse norm. Let me quit. Always clear the screen. So 0.9, and it's 410, and standard deviation is 72. 502. So you should score 502 or more. Sometimes students will use the 10% to find the answer. I want to show you what will happen if you use the 10%, guys, which is the 0.1. You score 317. Would it be possible for someone to score below average, which is 410, and be considered a top 10%? That's not possible. That means the 10% is not right. You have to use the area to the left, which is 90%. But for students who have the left, right, center calculator that shows this, you can keep 0.1 but put this is a right. Then it should give you 502 as an answer. 38. Now we're doing section 8.1. We're working with the samples. So this is about X bar, not X anymore. The only difference between working with samples and working with the original population is For x bar, the mean of the population will be the mean, but the standard deviation of x bar is the original standard deviation divided by square root of n, where n is the sample size. So what are the values of mu of x bar and sigma of x bar for this? Mu of x bar, guys, is 9. And sigma is the difference between two consecutive numbers. So 9.05 minus 9 would be what? 0.05. 39. Suppose a population has a mean of 7 for some characteristic of interest and a standard deviation of 9.6. A sample is drawn from this population of size 64. What's the standard error of the mean? The standard error of the mean, guys, is the standard deviation of the samples. Of the sample means, which is always a smaller standard deviation than the original standard deviation. It is sigma divided by square root of n. What is sigma in this problem here? 9.6. And what is n? 64 square root of 64. So it's 9.6 divided by 8, which is 1.2. And that would be the standard deviation. So if I ask you for standard error of the mean, it is sigma over square root of n. Number 40. 1 year professional sports players' salaries averaged 1.8 million with a standard deviation 0.9 million. Suppose that a sample of 100, so this is n, major league player was taken. Find the approximate probability that the average salary of the 100 players exceed 1.1 million. So now, guys, he's not asking for one individual, he's asking for the probability of the average. So it's a probability of x bar. And look how we're going to deal with. So probability of x bar greater than 1.1. Okay, that would be normal CDF as before, but you're going to see what's going to be different here. 1.1 is the lower bound. Upper bound, just put a million. The mean is what? 1.8. But the standard deviation, guys, is not 0.9. It's 0.9 divided by square root of 100. Don't forget that. Anytime the question is about x bar, the only thing that you change is sigma. Make it sigma over square root of the sample size. And if you want to do the math, that will be second and distribute. Normal CDF. 1.1. Oops, 1.1 millions. Mean is 1.8. A standard deviation is 0.9 divided by square root of 100, which is divided by 10. I get almost 1. So that is the answer, approximately 1. Next question, 41. Assume that blood pressure readings are normally distributed with a mean of 117 and a standard deviation of 6.4. If 64 people are randomly selected, what's the probability that their mean blood pressure will be less than 119? Again, this is a question about the x bar. It will be normal CDF. Okay, anytime you do less, guys, you begin with negative a million. 119 is your upper bound. The mean is 117. And again, don't put 6.4. You have to put 6.4 divided by square root of what? 64. And I'll let you do this. The answer should be 0.9938. 42. The standard error of the mean is given by what? I just told you. This is the formula for the standard error of the mean. 43. The owner of a computer repair shop has determined that their daily revenue has mean of 7,200 and a standard deviation of 1,200. The daily revenue totals for the next 30 days, so n is 30. What's the probability that the mean daily revenue will exceed 7,500? Exceed means more. And it's about x bar. So again, guys, that will be normal CDF. Okay, what's the first argument? If it is greater than, you begin with the 7,500, then you put a million, and then you put the mean, which is 7,200, and now don't put just the standard deviation. You're gonna put 1,200 divided by square root of what? 30. And if you do this, Your answer, if you use your calculator, which I don't mind if you do, is 0.0853. 44. Okay, I'm gonna stop the video here, and then I'll create another one for the last part, which is chapter 9.